scientific community is paused, forced to observe the sun in silence. The Three-Eye Atlas, the fastest and most enigmatic interstellar traveler ever tracked, has vanished completely from Earth's view. It is at the peak of its kinetic energy, at the perfect point for a maneuver that could rewrite the physics of our solar system. Since its discovery, this object has refused to fit into any category. Its chemical composition is controversial, its mass is gigantic, and its trajectory appears planned with impossible precision. Now, hidden from sight, the question is not whether it is a comet or an asteroid. The question is, what exactly is the Three-Eye Atlas, and what is it doing while no one can see it? On July 1st, 2025, the Atlas Alert System in Chile sounded the alarm. Preliminary observations confirmed a hyperbolic trajectory, indicating an origin outside of our solar system. It was the Three-Eye Atlas, the third confirmed interstellar visitor, but with characteristics far more extreme than its predecessors. Its speed is astonishing. The Three-Eye Atlas entered our system moving at 58 kilometers per second relative to the Sun, and will reach a peak of 68 kilometers per second at perihelion, scheduled for October 29th. This speed exceeds the velocity of the famous Oumuamua by more than 2 times. The coincidence is that this crucial date, the moment of peak energy, perfectly aligns with its solar conjunction. From October 21st until early December, Earth's line of sight is obstructed by the sun's intense glare. For astronomers, this occultation at the critical moment is an event of rare frustration. If the Three-Eye Atlas were a technological object, this would be the perfect time to perform an Oberth maneuver, subtly correcting its course with maximum efficiency, all while remaining unobservable. The anomaly of the Three-Eye Atlas began long before it disappeared behind the sun, unfolding into at least 7 enigmas that challenged the definitions of a natural celestial body. The first shock came with its size. The Three-Eye Atlas was far brighter than expected for an interstellar comet. Analysis of its dynamics suggested a nucleus that could be over 5 kilometers across, making it potentially thousands of times more massive than Comet Borisov. If it is so massive and is losing so much gas, the James Webb Telescope confirmed high carbon dioxide emission. Why isn't its trajectory deviating? The rocket effect should be noticeable. The absence of significant non-gravitational acceleration is what leads to the theory of its hypermass, the only way to counteract the momentum of the escaping gas, with an estimated mass exceeding 33 billion tons. The anomalies deepened with the chemistry. Spectral analyses revealed an extreme abundance of nickel in the gas cloud surrounding the comet, but a notable scarcity of iron. In all known comets and asteroids, these two metallic elements coexist in relatively stable proportions. This composition, nickel-rich and iron-poor, suggests some resemblance to nickel tetracarbonyl, a compound that, on Earth, is only produced in industrial refining processes. Could this be an engineered signature rather than exotic natural chemistry? Furthermore, the light reflected by the Three-Eye Atlas exhibits extreme negative polarization, an optical behavior that is inconsistent with the ice and dust that coat normal comets. Another mystery lies in the jets and rotation. Initial observations captured a dust jet that strangely appeared to be pointing towards the sun. Although the consensus points to a perspective illusion, some high-resolution data suggest the jet's geometry cannot be fully explained. Could it be a directional jet? Additionally, its rotation period is slow, around 16 hours, a stability that suggests a robust structure capable of withstanding sublimation forces without fragmenting. The anomalies become statistically impossible when analyzing the complete orbit. For an object coming from a random direction in space, the Three-Eye Atlas exhibits incredible precision in its orbital inclination, aligning to less than 5 degrees of the ecliptic plane where our planets reside. This precision is what enables its planetary tour. The 3I Atlas passed within 30 million kilometers of Mars in early October. In November, it will pass close to Venus, and in March 2026, it will pass near Jupiter. The probability of a random interstellar object passing so close to so many major planets is less than 0.005%. And to top off the list of mysteries, the arrival direction of the 3I Atlas aligns within 9 degrees of the origin point of the famous WOW signal, the strongest radio burst of unknown origin ever detected in 1977. The gravity of these anomalies led to an unprecedented response. While NASA reiterates that the 3I Atlas poses no collision risk, 270 million kilometers distance at its closest point, its unusual nature prompted the formal activation of the International Asteroid Warning Network, IWN. This UN-endorsed body, partially funded by NASA, launched a specific observation campaign aimed at enhancing orbital measurement techniques and testing the readiness of the global tracking community. For the first time, an interstellar object is subject to monitoring with planetary defense characteristics, not due to an impact threat, but out of an urgent need to understand its true nature. The IWN will hold workshops in November, focusing on how to precisely measure the astrometry of such an active and erratic object, ensuring that its return to the sky in December provides data with no margin for error. The Earth is not entirely blind. Space agencies have mobilized their probes. The ESA redirected its Mars orbiters, Mars Express and ExoMars TGO, to observe the comet in October. In November, the ESA's JUICE probe, en route to Jupiter, will observe the object as it moves away from the Sun. This data, once it reaches Earth, will be crucial, but it does not cover the October 29th window, the Oberth maneuver blind spot. Scientists predict that if the 3I Atlas is a comet, the intense solar energy could lead to its fragmentation due to thermal stress and rotation. The moment of truth will be in early December. The 3I Atlas will reappear in the northern sky, and major telescopes will be ready for the final mission, determining the outbound trajectory. If its position is even slightly altered from what gravity predicts, it will spell the end of the natural comet hypothesis. That small trajectory discrepancy will be the definitive proof that a mysterious acceleration occurred during its invisible passage. The 3I Atlas holds the potential to be a time capsule, a fragment of a destroyed planet, or, the most audacious hypothesis, an artifact of another civilization. The only certainty is that when it reappears in December, we will hold the key to unlocking the greatest cosmic enigma of our generation.